Okay, now we are in section 2, and we're going to talk about the second way that we can solve systems of equations. Now, if you remember from section 1, our first video, we talked about graphing, and we also talked about what exactly a system is. And if you remember, a system is just more than one line. Now, substitution is actually really easy because if you think about what the word means, substitution, well, let's think about that for a second. Substitute. The most relevant form of substitution to me is when you have a substitute teacher. If I'm out for the day or any of your other teachers are out for the day, you have a substitute teacher who comes in and takes our place. So that means that we are gone. You take us out of the school, and in our place, somebody else comes in. Okay, so that's the same idea that you're going to use when you are substituting. So just like with graphing, you can have one solution, no solution, or infinitely many solutions. With one solution, the system will have only one solution if you get one answer. So if you're solving for x and you get x equals 2 or x equals -4, that's one solution, and that's what the solution will be. And that'll be your x value. So of course, remember your solutions are ordered pairs, remember in graphing. So you'll have to plug back into the equation your x value and get a y, and your answer will be an ordered pair. Okay. If you have no solution, if you are solving your system and you get something really weird like 2 equals 4 or 0 equals 5, those aren't true statements. So when you get something like that, it means that you have no solution. Number 3, infinitely many solutions. So if you are solving and you get a true statement like 2 equals 2 or 0 equals 0, those are completely true. So that means that you will have infinitely many solutions. So let's look at a few examples. The best way to get this is to just jump right in. And just like with graphing, yeah, we have to check once we find our answer. All right, so let's look at example number 9. Now, in this example, you're going to notice that one of your equations is solved in slope-intercept form, meaning that it's solved for y, and the other equation is in standard form. Now, substitution, you're going to notice, works the best when you have one of each form. Can you use it in other circumstances? Yeah, you would just have to then convert one of your equations into slope-intercept form and leave the other one standard. Okay, so what's going to happen here is, like I said, we can see that this first equation is solved for y. Okay, and what y equals is 2x minus 14. Okay, so what that means is this 2x minus 14, you're going to take that and substitute it into this equation where y is. Okay, so this is going to look like this. Okay, all I did was I rewrote this second equation with the first one substituted in where y was. So instead of 7 times y, I have 7 times whatever y was equal to at the top. Okay, now it's just a matter of solving. We went over solving equations back in chapter 2, where we learned about the distribution property and combining like terms. So let's just go ahead and do that. I'm going to fast forward through this part because this should be review for you. So when you solve this equation, you should get x equals 6. And remember that our solution has to be an ordered pair. So that means that we need to find the corresponding y value that goes with x. How do we do that? Take x and plug it into whichever equation you want, to be perfectly honest. But please realize that if you plug x into the second one, how are you going to solve for y? You're just going to have to convert this into slope-intercept form, and then you're creating more work for yourself than you need. So I would plug this back into the equation that is already solved for y, okay, which is the first one. So that's going to look like this. Y equals 2x minus 14, and we said that x is 6. So plug that in. And we get y equals -2. Okay? So the y value of our ordered pair is -2. So our solution that we found for this problem is 6, -2. However, yes, just like with everything in this chapter, we do have to check. Now, when we were graphing, we had to check our solution into both equations. The nice thing about substitution is that you only have to check it into one, okay? And it's really preference. Whichever one you want to use is fine. Some people think it's easier one way. Some people think it's easier another way. I'm just going to plug it into the first one. Okay, and when you plug it in, you get -2 equals -2. Yes, check mark, that is true. So we checked it, and we know that this is going to be our correct solution for this system of equations. Okay, let's do one more here. Number 10, I'm going to kind of fast forward through this one now. You should know how to do this. Once again, we have y equals -3x minus 10. So we're going to take that y and plug it into the first one where the y is. Okay, so we're going to take this and plug it in here. We have 6x plus 2 times -3 minus 10. Oops, -3x minus 10. Equals -20. Okay, so let's solve. Uh-oh. Look what's happening here. 6x minus 6x. Well, 10 minus 10 is 0. A million minus a million is 0. So is 6x minus 6x. Okay, so we have -20 equals -20. We have a true statement here. Now, what does it mean when we have a true statement like 2 equals 2 or -20 equals 20? That means we have infinitely many solutions. How can we check that? Well, we said in section 1 that if lines have infinitely many solutions, if they are the same line, then these should be the same exact equation, okay? So let's convert this first one into slope-intercept form so that it's y equals, just like the second one. And if they come out to be the exact same equation, then we know that it's infinite solutions because they are the exact same line. So the first equation was 6x plus 2y equals -20. To put this into slope-intercept form, I want to solve for y. So that means I need to move 6x to the other side. And I have 2y equals -6x minus 20. And then divide everything by 2. And I get y equals -3x minus 10. Okay? Does this look exactly like the second equation? It sure does. So these are the same line, meaning that they, yes, will have infinitely many solutions. Okay. Let's flip to the back page. Okay, on the back we've got 11, 12. I'm going to skip those 2 and jump down to 13, 14. I'll do some more examples. I'm going to go pretty quickly, okay? So make sure you follow along. Number 13, we have y equals -2x plus 6. So we're going to take that y and substitute it into the second equation. Remember, substitution. Here we go. All right, when you get done solving, you get x equals 2. We have to find our y coordinates, so that means plug this back in. I would plug it into the first equation here. We've got y equals -2x plus 6. Plug 2 in for x. We get y equals -2 times 2 plus 6. Y equals -4 plus 6, which is 2. So we get a y value of 2. So our solution to this answer is going to be at point 2, 2. we need to check. Don't forget to check. So to check, we're going to plug in x and y, and either equation. It doesn't really matter which one, okay? So I'm going to kind of do it over here on the side. We've got y equals negative 2x plus 6. 2 equals negative 2 times 2 plus 6. 2 equals negative 4 plus 6. So does 2 equal 2? It sure does. Check mark. So we know that this is a correct solution to our system. Okay, let's go over to number 14 quickly. I know this video is getting kind of long. We have y equals negative x minus 10, and here's y in the other equation. So we're going to substitute this whole thing in for y, okay? So negative 6x plus 3 times y. So when you solve, you should get x equals negative 1. We have to find our y value, so that means to plug negative 1 back into the equation. Y equals negative 5 times negative 1. And you get a y value of negative 5. Okay, so our solution is going to be at negative 1, negative 5. How can you check that? Plug it back into either one. I've been plugging it into the equation that's solved in slope-intercept form. I'm going to switch it up this time and plug it into the second one and show you that it does the same thing. Okay, so I'm going to turn my paper sideways because I'm running out of room here. Negative 6x plus 3y equals negative 9. So I'm going to plug in x and y, and I get negative 6 times negative 1 plus 3 times negative 5 equals negative 9. We have 6 minus 15 equals negative 9. 6 minus 15 is negative 9, so does negative 9 equal negative 9? It sure does. So check mark, we checked our work. It turns out this is the solution for this system. All right, so lots of work with substitution. I want you to try 15 and 16, and don't forget 11 and 12 that I skipped up here on top. Do these last examples. Make sure you have them done before you come to class, and don't forget those summary questions. Have a good night.